Hello, and welcome to today's session on securing your galaxy. My name is Enis Afgan. I'm a research scientist at Johns Hopkins University and one of the PIs of the Galaxy project. I'm accompanied today with Anurag Shankar, who is a senior security analyst at Indiana University's Center for Applied Cybersecurity Research. His expertise lays in regulatory compliance and cybersecurity management. He will share some details with us about how we can improve the installations of our Galaxy instances, and I will provide some context on some of the decisions that were made along the way. So to set some context why we're here and what will we cover in today's session, the focus is how do we secure our Galaxy installation. Oftentimes when we think about security, we think about it from the technical implementation perspective, yet security is broader than that. So in addition to the technical implementation of the software, there are processes that need to be put in place, and there are people that need to ensure that those processes are fulfilled. As a result, we will sort of take a broader approach to securing your Galaxy installation rather than looking at purely the technical implementation or the deployment details, and look at a template of how we can combine all of these components to secure our Galaxy installation and hence improve the security posture of Galaxy. So to motivate this, and why is this coming up to the surface only now, is because it was inspired by a couple of funded projects that the Galaxy project has received. One being the Anvil project. More information is available at anvilproject.org, and the other one is Galaxy for Cancer. These projects, the implication with them is that they work on human data, and as a result, much of this data is protected. So the use cases are human genetics and access to these Galaxy instances and to the data that people and users operate on have to have a more stringent access policies and security surrounding these Galaxy installations. And so while this is the motivation and this is the main thrust behind some of these activities, the implications and the reason for why we are here today is that we can share our recently acquired knowledge and distribute this to a more broader community so that the community can take it, expand it, use it in their own environments, especially if they have use cases that are similar to the ones driven by the two driving projects in this case. And so this process has been going on for several months at this point. The steps that we have taken thus far, we will basically summarize in the remainder of the seminar today. So to start, in July, we performed a security audit through an external contractor of the CloudMan application in Galaxy on Kubernetes deployment. We received a report about the recommended enhancements, some deficiencies, and we are actively working on those to improve the security of that particular deployment mechanism. In addition to this very focused activity, we have undertaken a 6-month-long engagement, about which I'll talk about more, and so will Anurag, with Trusted CI to lay some of the groundwork for improving the security posture of Galaxy in very specific deployments, but also to provide a more general framework that can be reused by others in the Galaxy community. And so looking forward and to the future, our goal today being the first such event is to disseminate the results of this effort to improve the security of Galaxy as a whole. And future sort of more practical steps are to craft an implementation and an operation plan at the Galaxy project level that implements some of the recommendations in the documents that we will look at for the rest of the day. I will now hand it over to Anurag, who will give you a little more information about Trusted CI.
Trusted CI is the National Science Foundation's Cybersecurity Center for Excellence. Trusted CI's mission is to create an ecosystem for the National Science Foundation where the workforce knowledge and processes having to do with cybersecurity can be developed, as well as cyber infrastructure that can help enable a trustworthy science that is trusted science that is created using cyber infrastructure that has been secured and has that assurance of creating science that can be trusted by the practitioners as well as the consumers, that is the public. Also to lead the nation in research and innovation. Trusted CI develops training materials on various topics such as incident response. We also create templates for policies and procedures that you might want to implement at your institution, software assurance modules, and vulnerability awareness and other kinds of tools. There's a whole series of tools that we provide. There's also a community which includes a mailing list. And we have a monthly webinar series. Also, we lead the National Science Foundation's large facility security team. This is a team of sites that are funded by NSF, large facilities such as the Scripps Institute of Oceanography and other sites. And they come together and talk about cybersecurity topics of interest. NSF community also benefits from the webinars that Trusted CI presents. These are monthly and are presented on the fourth Monday of the month at 11 a.m. Eastern. And these cover all different types of cybersecurity topics, also compliance topics, such as the ones listed here, GDPR, HIPAA, and FISMA, which is the topic of interest today. Trusted CI also partners with the Science Gateways Community Institute, also known as SGCI. Some of you may be familiar with it as being part of the Galaxy community. Trusted CI partners with them and provides direct support, cybersecurity support to SGCI, and also provides training boot camps and webinars and other resources. You can go to trustedci.org/SGCI to learn more about our partnership. Another very important service that Trusted CI provides are engagements. These are cybersecurity engagements, which can last from a short period of time, weeks to 6 months, where you can apply for if you have a small or a large National Science Foundation funded project or facility having to do with cybersecurity, and these applications are then reviewed, and if your project is chosen, such as this Galaxy project that Enis is talking about, we will engage with you and help you with any number of topics having to do with developing your cybersecurity program, or doing an assessment, or helping with, for example, identity and access management, software assurance, and any number of topics where you need help with cybersecurity. So in order to leverage Trusted CI, please go to trustedci.org/help, and you will find other links there. Also events that we have. There's an annual cybersecurity summit that we host, and engagement application and various other resources are available at that website.
So now that we've learned a little bit about Trusted CI and the role that this group plays in the academic domain of cybersecurity and risk management, I'll just say a couple words about how we came across Trusted CI and what the engagement application process was like. So the engagements are available through the Trusted CI site for primarily NSF-funded projects. If you do not have a currently funded NSF project, it doesn't mean you shouldn't apply, but preference is presumably given to the NSF-funded projects because Trusted CI itself is NSF-funded. The application window happens twice a year. It's a 2-month window during which you can apply for for an engagement, if you would like to do a similar process that we've gone through for your own Galaxy installation or your other projects unrelated to Galaxy, if you have them. In the past, these windows have covered February and March and August and September months, and then about a month later, at least in our case, you hear about the outcome of the application. The application itself is about 25 questions through a web form that asks you to write about the project description, the motivation for the engagement, and the desired focus, whether you want to focus on, for example, improving the compliance the compliance posture, or do you want to look at the code itself? Do you want to do penetration testing on the code? There's about a dozen different examples of tasks that the engagement can cover. And so we were lucky enough to have been selected for the 6-month engagement with Trusted CI. And again, the outcome of this is going to be presented for the most part in this seminar. So the goal of the engagement was to review the security of a deployment model for Galaxy. And the outcome is that we learned some steps how we can improve the deployment model at the framework level, but also that we can create a report, a document that can be disseminated into the community in case they want to take it on and implement components that are site-specific. So the engagement activities revolved around a weekly meeting during which we would go through the Galaxy architecture details, talk about the data flows and how data moves across the Galaxy environment, existing safeguards that exist at the framework and the Galaxy application level, and the software development practices that are applied at the Galaxy project. Trusted CI used the NIST 853 control catalog to guide these discussions and inform the final report. And so, which is the final outcome of this engagement. The final report consists of a series of recommendations on how to improve Galaxy's security posture. And I said we will go through this report today, as well as share it more broadly with the broader Galaxy community. And with that, I will hand it over to Anurag again to talk about the next phase of the engagement.
So this process that we used with the Galaxy project comes from experience that we have gained at one of the Trusted CI partner sites, Indiana University, where almost over a decade ago, when we had to address HIPAA compliance for research computing systems, we decided to start with a HIPAA specific process, but then soon it became clear that other types of compliance regimes are going to be coming and will need to be addressed. And therefore, it was better to actually follow a mature cybersecurity standard, which would be able to handle multiple compliance regimes at once, not just HIPAA. And so we looked around and found that the NIST risk management framework was one such standard that was being used by the government, also outside the government, but it was used by the government agencies to comply with the regulations, particularly the FISMA regulation. And it was based on a mature cybersecurity standard, a large catalog of controls called NIST 800-53, which could be used. And because of the fact that it was a large control catalog and the fact that cybersecurity controls are controls and they're not specific in their basic form for different compliance regimes, there simply happen to be a slightly different subsets, often very highly overlapping. We can use that particular standard. And this allows us to map the controls that any particular compliance regime might require by simply mapping that to this large catalog. And this allows you to, as I said, use a single process to comply with multiple compliance regimes. And in one word, you can then do security and not compliance. In other words, you try to align with a mature standard, and compliance essentially falls out of it as a byproduct. Since I spoke about the NIST risk management framework, also known as RMF, in compliance, I think it would be useful to connect the various terms that you may have heard, such as FedRAMP 800-53, which I described earlier, and HIPAA, and how, again, what is the connection between all of these different things? So as I mentioned earlier, the NIST 800-53 is a special publication by NIST, a large catalog of controls, about 1,000 controls, which are arranged in control families, such as access control, awareness and training, incident response, and et cetera. And each control family has a number of controls. So this is also sometimes called a security standard, but more accurately, it is a control catalog, again, used by the risk management framework to manage cybersecurity risk. I mentioned the word FISMA. FISMA is a regulation that each government agency has to comply with. And what the regulation asks is for the agency to put in place a NIST risk management framework using the 800-53 controls. Since a lot of computing has gone to the cloud, and because the government wanted to use the cloud, they set up a program called the FedRAMP program, which allows a cloud vendor to get a certification from the government to essentially be compliant with the RMF and 853. So if a cloud vendor has put into place the RMF and all of the required 800-53 controls at the appropriate level, and the controls can be at a low, moderate, and high level, which simply means that there are a increasing number of controls as you go from low to high. If the cloud vendor has them in place, then they can get certified, and this certification called FedRAMP. HIPAA, as you know, is a federal regulation which protects identifiable patient data in the healthcare context. That is patient data that was created in a healthcare setting by a healthcare organization, health plan, for example, health clearinghouses. And the connection, as I mentioned earlier, when I talked about why we chose this approach, is that HIPAA is a set of controls which easily map to the large catalog 800-53. Therefore, if you follow the 853 catalog or use those controls, then you can map HIPAA to NIST. And that way you can handle HIPAA as well as other compliance regimes. Now, there will be some controls that don't map between HIPAA and 853. And so, fortunately, a very small number of controls, and you basically address them separately. And that way, again, you can use that single standard 800-53 to do multiple compliance regimes, including a new one that is called 800-171, which is a smaller subset of controls, which are from the 800-53 catalog. And this is something that's relevant to the Department of Defense right now, so I'm not going to talk too much about it here. A couple other things I should mention that are on the slide is the risk management framework, essentially the life cycle approach to managing risk. which starts with a system categorization. You categorize the system based on the impact a breach would have on the organization. And then you select the controls which are relevant, that actually applicable for that particular system. You implement those controls, you assess those controls to make sure that they are doing what they're supposed to do. You have a process in place that you go through in order to get the system authorized for operation. You monitor that system as you go forward, and the cycle completes. The other thing I should mention is that the mapping between HIPAA and NIST 800-53 is provided by another NIST document called the NIST 800-66. This already does the job for you. So having described the connection between NIST and HIPAA and FedRAMP, let's get down to the details of how we went about getting Galaxy toward HIPAA compliance. The first thing that we need to talk about in this process is something called a System Security Plan, or SSP. A System Security Plan is basically a document that describes the system and also the NIST 800-53 controls that you have in place, the applicable controls that you have in place. It is essentially the primary document that basically describes your due diligence. The FISMA, for example, requires an SSP, and so that's where the term SSP comes from. But you could basically have a system security plan. You could call something you do basically describing your controls a system security plan. It doesn't have to be 800-53. And so this is the process that we used to document Galaxy as well, and Enis is going to talk about exactly how.
The engagement itself that we performed with Trusted CI focused on one deployment model. Meanwhile, Galaxy has a number of deployment models to accommodate different scenarios in which Galaxy is run. As a result, the engagement is applicable to one specific type of deployment, but many of the steps, I will say, are applicable to anything, even if you don't necessarily use the infrastructure and the framework that we've chosen to work with during this engagement. If you'd like to see and cover all of and learn about all the deployment models that exist for Galaxy, there are some slides and a video of a webinar that was done recently in the links below. And so the deployment model that we selected for this particular engagement was the one of Galaxy on Kubernetes. The reason we chose this is because it offers a production deployment of Galaxy with best practice services out of the box. With a handful of commands, you can get everything that a production-grade Galaxy requires. And secondly, this particular deployment model is the one used for the driving projects, namely Galaxy for Cancer and Anvil. And as a result, again, that inspired our decision-making. And so, again, the outcome of this, or an outcome of this engagement, is an SSP document that Anurag introduced to us, and we will go through in more detail for the rest of the seminar. This SSP consists of recommendations and controls that include both technical advice as well as site-specific clauses that would have to be implemented on a specific server or a specific site. Many of the recommendations that we have received, and we've only received this document recently, and so not much has been implemented yet, but the ones that can be implemented at the framework level, we will strive to do so. And as a result, anybody that adopts this framework for the deployment of Galaxy at their site gets those recommendations implemented basically for free. And The site, as I mentioned, the site-specific advice is dependent on the needs and the abilities. So if you're not dealing with highly protected data or private data, maybe not all of the recommendations apply, and hence there's no need to cover them all. As a result, it is left up to sort of the abilities of the deployer to consider which ones are applicable and should be implemented. And with that, I will turn it over to Anurag again, who will go through the SSP and talk about various recommendations and various controls that exist in that document.
Okay, so let us get into the Galaxy SSP. So the first thing I'm going to do is to just introduce you to what an SSP is, its structure. Then I'm going to go into the details of what cybersecurity Galaxy provides as it's distributed, and what security you must have in place in order to make sure that you are compliant with HIPAA or other regulations. So again, a system security plan can be a very large document, but it need not be. It describes the controls in place. And again, it's a document that has been created for an auditor, and it's not a functional document in the sense that it is not a document that is to be used by, let's say, a sysadmin to actually perform some sort of action. This, again, describes the controls that are in place, and therefore it describes your due diligence. So the document essentially is, and I'm going to run past the table of contents here, starts with a system characterization. So it talks about the system name, for example, what type of system it is, a categorization of system, and I talked about that as part of the RMF, and whether the system is in production, etc. Talks about the contacts, who are the people responsible for the system. This is always an important section in any security document. Then it starts talking about the system itself in a little bit of detail, exactly what the system environment is, what the boundaries are, which means what part of the system is in scope. It might be just the basic system itself, or it could be something external to it that is also in scope for the particular kind of compliance you're doing, or depending on where the protected health information, for example, is flowing, and dependencies, because the security of the dependency also, of course, comes into play. It also has, generally speaking, has figures of how system components are interconnected, also what the data flow looks like. And these are important things to understand in order to have some idea about what needs to be secured. In some sense, you need to know what you have or what security is in place in order to understand where you need to go. The system is then, the system security plan is then followed by a description of what the system boundary looks like. It's the dependencies, external dependencies, for example. It certainly depends on your network infrastructure, things like services and so forth. Then this is just a list of documents that were used. And then it gets into the nitty gritty, or the meat of this document, which is the actual security controls. And so, as I mentioned, the 800-53 has a number of control families. And so this gets into the individual controls of each control family, for example. As I mentioned, the first one is access control, which is the most important control families. So it talks about all the controls you have in place. The first control in each control family is about about policies and procedures, which are very important because especially in HIPAA, the administrative controls are very important. In fact, they comprise most of HIPAA controls. Technical controls are only 20% or so of HIPAA. And therefore, you have to pay attention to the policy and procedures. They have to be in place. They have to be documented. Again, I will go through the controls in a little bit. Just wanted to show you the various control families, just the structure of the document. So we get into all these different control families. Security assessment, configuration management, contingency planning, identification and authentication, incident response, maintenance, media protection, physical and environmental protection, data center controls, basically, planning, cybersecurity program management, personnel security, this is HR, risk assessment, system and services acquisition, system and communications protection, and system and information integrity. So these are the control families and the controls in place. NIST 800-53 also has privacy controls, but we're not going to cover those. They also mentioned that a system security plan, I mentioned that the 800-53 doesn't cover all of the HIPAA controls, and therefore a system security plan, you put in a page that talks about the HIPAA safeguards, which are not covered by NIST, and there's not that many of them. One of them is a business associate contracts and so forth. So you address them explicitly in a separate part of the document. So that's the structure of a system security plan. So let's go back and we will talk about Galaxy specifically. So when you are documenting your system, that is, again, if you get the distribution, you implement it at your site, then if you are following this particular kind of process, then you would document it the way this is documented. And so what I'm going to talk about is not so much the documentation part of it, but about what controls Galaxy has in place and what controls you have to have in place in order to complete that, complete the picture. So let's get into the individual control families again. We're going to go to AC, as I mentioned, is the most important control family. So as I mentioned, policies and procedures are going to be things that you have to have in place at your site. Again, these are very important parts of HIPAA, so you must have those in place and documented. You don't have to have those policies and procedures actually included here, but you should have them somewhere and you can point to them. If it's in a website, you can simply point to the website, for example. Account management, again, this is an inventory of types of accounts you have. The idea is that you have that, you have to know what you have in place in order to secure it. And again, going back, sorry. What types of accounts means user accounts, system accounts. Again, in this particular case, again, this is talking about the built-in namespaces and user accounts that Galaxy has. And these may be most of the accounts that you will have for when you have your own implementation of Galaxy, but it depends on, you may have other infrastructure that supports Galaxy, and those accounts may have also to be in scope. So that will have to be documented here. Again, remember the site dependent controls are the ones where you will need to have some safeguards in place. So again, who manages accounts? These are things, whether there's a group that manages accounts. The idea is that you don't have ad hoc account management. You actually have some sort of documented process for it. Who approves account creation? Who approves these accounts? What are the procedures for account creation? For example, do you have a documented process for creation, activation, deactivation, and so forth? Are you monitoring accounts? For example, are there a lot of stale accounts, for example? Are you going and looking at accounts every 6 months to make sure that there's accounts that are not being used, are at least being disabled, or whatever the policy that you might have in place? This is an important control, so that's covered here. Again, I'm not going to talk about these in a lot of detail, but access enforcement is a good example. Galaxy uses has access control mechanisms in place, for example, password and SSH keys, permissions and roles, and so forth, digital certificates. So those are built into it. However, you may have to have AC2I in place, authorization of information access. There may be certain types of information that only certain people can get access to. So that would be a complementary control that you have to have in place. Again, documentation is something you have to have in place. Least privilege, Galaxy architecture itself implements least privileges. For example, different services are running as, for example, as unprivileged users, and you should try to run things as unprivileged users where possible. So that is another example of things that Galaxy people have done, the Galaxy team has done, and the things that you will have to implement. Unsuccessful logon attempts. Again, these are local policies you have in place for operating system, for example. Make sure that SSH sessions time out. Sorry, that's AC12. I'm sorry, I'm getting ahead of myself. AC7 is about making sure that that you have some limit on unsuccessful logon attempts. So by configuration, for example, if there's 25 unsuccessful logon attempts within 10 minutes, then that account is locked, that kind of thing. Session termination, again, is an important control. So this is this describes the kind of sessions that Galaxy allows, and therefore you have to actually implement, including either Galaxy configuration or SSH configuration, auto log off. Again, that's a requirement in HIPAA, so that has to be in place. If you have external systems, for example, Galaxy is connecting to external systems, and that's impacting the security of your installation, then that has to be addressed. And again, this talks about the systems that Galaxy itself connects to, and makes sure that those systems are secured. Awareness and training is going to be an entirely local control, obviously, for really obvious reasons. This is stuff that each site must do on their own. And so this would be a control that you have to implement locally. Awareness training, role-based training. So sysadmins might need to take security training, for example. Users may need to take HIPAA training. That's a requirement of HIPAA, for example. AU is another very important control family. It's about audit and accountability. It's about logging mostly. So, for example, this documents the kinds of things the Galaxy itself is auditing and is logging, but you have to determine, again, by AU2C is what events that you must audit. For example, the rationale may be that every action on the system must be traceable to a unique user, for example, and exactly what sorts of things must be logged in order for that to happen. In other words, for forensics to be successful. So these are decisions that you must make in order to comply. AU5 is an interesting control. I wanted to mention it because it's about monitoring whether logging itself is working. Again, that's something you will have to, again, make sure syslog D is running, for example, via some mechanism, and that logs are actually reviewed. So you might have ELK, for example, to review logs, or Splunk or something like that. Again, these are local things that you have to have in place, and making sure you have security assessment. For example, penetration testing would be one, making sure that you have monitoring in place. Again, this talks about the kinds of things that Galaxy itself is monitoring. But if you look down here, you may have monitoring in the data center, for example, and other things that you have to monitor using your own mechanisms. See, it mentioned penetration testing. That's something that might be useful to do, a good security assessment technique. Configuration management, this is going to be something that you're going to have entirely your own installation for that. That means that you may have Ansible scripts and other things to implement. Galaxy provides some scripts and all that you can use, but for operating systems, for example, you may have Puppet, Chef, things of that nature. You have to have that, deal with that. Least functionality, again, the Galaxy makes sure that many of the different components have the least functionality. In certain cases they do, in certain cases they don't, but it's documented here. You would have to make sure that you have complementary controls in place for operating system or any other things that you might be running. Inventory, this is something you have to have. Basically, you have to know what you have before you can secure it. So this is a very important control to have in place. Other things, if you're allowing users to install software, which is generally not the case in Galaxy, but if there's parts where users are able to install software, then if this was some other system, for example, that would have to be addressed here. Contingency planning, this is a disaster recovery, is a requirement in HIPAA, so you have to have that documented plan in place to have some sort of a plan. There's also testing, so you have annual, for example, some sort of a tabletop exercise. Backups are part of it, so you have to make sure that protected health information can be recovered. Identification and authentication is the next control family, and this is where while Galaxy provides you with namespaces, you may have your own institutional authentication that you might use. And if you do so, then you would need to make sure that that part is properly secured. So this goes over choosing usernames, how usernames are chosen, how people's identities are verified. For example, how passwords are secured. What's the password strength, for example? If you distribute passwords, then you do make sure that you're distributing it to the right people. If you have a password change process, that is properly secured, and things of that nature. These are controls that you have to have in place. Incident response is a HIPAA requirement. This is you have to have policies and procedures for incident response in place, and also incident response training. You need to make sure that you have, for example, annual tabletop exercise, and essentially publish a address, a very clearly identified procedure that people know about and can, for example, have an email address where people can email in case there's an incident, or a phone number where they can call. These are things that you need to have in place in order to comply with HIPAA. Maintenance, again, this is about making sure that the system is being maintained. Again, hardware maintenance, for example, who approves maintenance. These are the kinds of controls that that have to be in place. Again, the right types of personnel that are doing this training, and there's making sure that these are approved methods for doing that. There is media protection. Again, these are your local controls, making sure that systems are sanitized before they before they're disposed of, and also just removable media and controls associated with those. This is about data center controls. Again, these are things that are going to be purely local. Security planning, the system security plan itself is kind of part of that process. Cybersecurity program you have in place, and that's actually the very first part of HIPAA. You have a risk management process basically, and that's what this thing describes. And going back, that you have someone who is tasked with security, that's an assigned security responsibility control in HIPAA, so that's a requirement. Someone must be security lead, for example. This is about HR, so making sure that there's background checks, for example, and that there's a process in place to remove access when someone is terminated, for example. The risk assessment is a part of risk analysis, as it's called for HIPAA. That's a requirement. You must have a regular risk assessment, annual, for example. You need to know exactly what risks you have before you can do something about it. This is about when you do acquisitions of equipment, for example, that you have security in mind, and basically as you develop the system and system development life cycle approach to security. This is more sort of typical technical controls that you think of. Firewalls, again, these are all local controls. Transmission, confidentiality, integrity. Obviously, Galaxy provides mechanisms. For example, SSH is something that you would have in place, and again, that's because by virtue of the fact that the Linux systems, but also they provide a mechanism through which you can have a secure web service, for example, secure servers and so forth. But of course, you have to get your own security keys and that those kinds of things, and other web security, for example. This is about patching, flaw remediation. Again, these are your local controls for anything you do, testing, for example. Malicious code protection. This is about antivirus, for example, for your workstation and also systems. Monitoring, system monitoring. These are local controls that you have to have in place. NIST comes with privacy controls, but we're not addressing that. And finally, as I mentioned, that there are some HIPAA controls, HIPAA safeguards that do not map to NIST 800-53. And so those are explicitly covered. One of them is the business associate agreement, which means that if you have downstream vendors that are able to see a customer's protected health information, then you must have a business associate agreement with them. And generally speaking, if someone else is giving you their protected health information, that they will have a BAA with you. So that's the BAA. There's also a 6-year time retention requirement, documentation retention requirement for any compliance documentation, and that it has to be available to the people that need to have access to it. So these are, this is the system security plan and the kind of controls that you have in place. And as you can see, many of these controls are local controls, the controls that you have to have in place as part of your installation. However, there's controls that are provided by the Galaxy team as part of their distribution. So keeping in mind the fact that it's always a joint effort between Galaxy team and you, with you bearing most of the load here, making sure that your system is secure. But if you have these controls in place and with proper business associate agreements, then it is possible to use this approach to become HIPAA compliant, and actually use this approach to do compliance with any rule and regulation in essence via mapping. So this hopefully was useful for you in order to do security. And again, if you have NSF funded projects, there's always Trusted CI that you can come to for help. And certainly Enis and the Galaxy team would be happy to help you as well. So with that, we're going to finish this presentation, and thank you for attending, and have a good day.